Hello students, welcome. In our previous classes, we were dealing with topic 3 of Form 4, which was chemistry of rates of reaction and reversible reactions. So today, we are going to proceed to topic 4 of Form 4 work. The name of the topic is electrochemistry. We are going to start our first lesson, and we are going to start by defining what electrochemistry is. So electrochemistry is a branch of chemistry that deals with the chemical changes produced by electricity and the production of electricity by chemical changes. Electrochemistry deals mainly with the first one, redox reaction. In other words, oxidation reduction reactions. Number 2, it deals mainly with electrochemical cells, which are also known as voltaic or galvanic cells. And number 3, we are going to have electrolysis, which we are going to deal mainly by non-binary electrolyte. Okay, we are saying each of these areas will be discussed in details. Okay, let us start with the first one, that's redox reaction. In other words, oxidation reduction reactions. So what is redox reaction? So redox reactions are reactions in which both oxidation and reduction processes occurs simultaneously. So we're saying redox reactions involves electron gain and electron loss. So we want to see the difference between oxidation and also reduction. So in the table, we have the first row as oxidation can be defined as. In this other column, we're having reduction can be defined as. The first one, remember in Form 1, Chemistry, Chapter 4, that's air and combustion, we were defining the term oxidation. And we are saying oxidation is the addition of oxygen to a substance. Then we are saying reduction is the removal of oxygen from a substance. So we can define oxidation as addition of oxygen to a substance, while reduction can be defined as loss of oxygen from a substance or removal of oxygen from a substance. Number two, oxidation can be defined as loss of hydrogen to a substance, from a substance. Then reduction will be addition of hydrogen to a substance. Okay, again we can define oxidation as loss of electron from a substance. Then reduction can be defined as gain of electron to a substance. Then lastly, we can define oxidation as increase in oxidation number, while reduction we can define as decrease in oxidation number. So during the exam, you will be told define oxidation in terms of electron transfer. We are going to say oxidation is loss of electron from a substance. If you are told define reduction in terms of oxidation number, so reduction will be decrease in oxidation number. So we go next, we are told note. We are told reducing agent is the species or the substance that undergo oxidation, while oxidizing agent is the species or is the substance that undergoes reduction. So here we have 4 terms. One is oxidation, the other one is reduction. The third one is reducing agent, then the fourth one is oxidizing agent. So if you know the substance that undergo oxidation, you will know automatically that is the reducing agent. So if you know the substance that undergo reduction or the one that's been reduced, it will be the one that's the oxidizing agent. So oxidation will go with the reducing agent, reduction will go with the oxidizing agent. Next, we are going to go to examples of redox reactions. Number 1, we have reaction of metals and dilute acids. Example, we're having zinc reacting with hydrochloric acid. We are going to get zinc chloride and also hydrogen gas. Number 2, we have the reaction between metal and also water. For example, we're having potassium reacting with water, giving us potassium hydroxide and also hydrogen gas. Then number 3, we have displacement reactions. We are saying when iron filings are added to a solution of copper 2 sulfate, the observation that we are going to see is a brown solid, which is copper metal, is formed. The color of the solution changes from blue to pale green or light green, and that's due to the formation of the iron 2 ions in the solution. So I want to write the reaction, the balance, the chemical reaction. And here we are having iron filling. So here it will be Fe, which is solid, reacting with copper 2 sulfate. We are going to get the iron 2 sulfate solution, which is FeSO4 aqueous plus copper solid. So the ionic equation there will be iron 2 metal or solid reacting with copper 2 ions, giving us iron 2 ions and also copper metal. So we are saying the reaction between iron and copper 2 ions involves transfer of electrons from iron atoms to copper 2 ions. The reaction can be used to keep track of the transfer of electrons during the reaction. Like in our case here, we have the electrons moving from iron metal and going to the side of copper 2 ions. So this can be illustrated by writing half ionic equations or ionic half equations. So here we are having iron metal. So we are going to write iron, which is solid. So what happened to iron? So for iron to have Fe2 plus means lose of electrons. Okay, when a metal loses electron, it is given a positive charge, and that is due to the high number of protons compared to the electrons. Because when an element or a metal loses electrons, the number of electrons becomes lesser compared to the number of protons. So if it loses electrons, we are going to write the arrow, then we are going to write Fe2 plus solution, and electrons lost are written on the product side. We are going to write those electrons lost on the product side. Okay, what is this? Because iron is losing 2 electrons to become iron 2 ions. So this is the reaction for oxidation process. Oxidation process. Okay, let's go. The other one again, we are having copper 2 ions. Copper 2 ions aqueous. So when copper 2 ions like this is that it has already lost 2 electrons, but when we check to the product side, we're having neutral copper metal. So what happened? So that means it has gained the 2 electrons that it has initially lost. So when it gained the 2 electrons lost, there we are going to get neutral copper metal, which is solid. So when a metal or an atom is gaining electrons, those electrons that are gained are placed on the left hand side of the arrow. Okay, so what is gain of electron? Gain of electron is reduction. So we can check here. We are having oxidation is loss of electron, so reduction is gain of electron. Okay, so this will be reduction process. So remember, during the exam, you can be told to write the half ionic equation for the oxidation process and also for the reduction process. That's how we are going to write. So remember, we were dealing with examples of redox reactions. We were having the first one to be metal and acid reaction, the other one metal and water reaction, the third one displacement reaction. So we are told, note, neutralization reactions and precipitation reactions are not redox reaction. The reason is, we are told this is because they are not accompanied by change in oxidation number, or they are not accompanied by transfer of electrons. So let's see examples. So example 1, we are told with the reason, state whether the reactions below are redox reaction or not. A, we're having copper metal reacting with silver sulfate solution. We are going to get copper 2 sulfate solution and also silver metal. So this is a displacement reaction, we can see. So what is displacement reaction? Obviously, displacement reaction is a redox reaction. So we are going to say here is redox reaction. So what is the reason? Because we are told with the reason. So the reason we can give several answers. The first one we can say the reaction involves transfer of electrons from copper metal to silver ions. That will be the first reason that we can give out. Second, we can say this is because it involves, or the reaction involves both oxidation and reduction reaction or processes. We can also say like that. Number three, we can talk about the electron transfer. Like we can say copper metal loses electron, hence it undergoes oxidation, while silver ions gains electrons to become or to form silver metal, hence that's a reduction reaction. We can also say like that. So we can say this is because copper metal lost electrons, hence undergoes oxidation, while copper 2 ions gains electrons, hence undergoes reduction. Therefore, the reaction is a redox reaction. So, but B, this one is a precipitation reaction. So we are saying precipitation reaction is not a redox reaction. So I'm going to say not a redox reaction. The reason for this, it is here. This is because they are not accompanied by changes in oxidation number. So that's the end of our video today. Thank you.